Good day, students. Welcome to a new day of learning. For today's lesson, I will discuss to you about the subatomic particles of an atom. This is Module 5 of Grade 8 Science entitled The Subatomic Particles of an Atom. For the objectives of this module, we have two objectives. First, we have to identify the three subatomic particles with its charges. Second, compare the masses of the subatomic particles. Before that, let's recall our previous lesson. First, all matter has its particular state, meaning this original state of matter before it changes to another state. Second, all matter undergoes phase change. This is the transition of matter from one phase to another due to the alteration of temperature by adding heat or by removing heat. Third, we have 6 phase changes. These are melting, freezing, evaporation, sublimation, condensation, and deposition. Fourth, we have to remember that phase change that occur when heat is added are melting, evaporation, and sublimation. These changes requires heating that makes the molecules move fast and move apart, causing the attractive band to break. Fifth, there are also changes that occur when heat is added. These are freezing, condensation, and deposition. These changes require cooling or removing heat that makes the molecules move slower and closer, forming a very strong attractive band. An atom is the smallest particle of matter. This is according to John Dalton. John Dalton says that all matter is composed of extremely small, indivisible, indestructible particles called atoms. The atom is the smallest particle of matter that cannot be divided using a chemical means. But atoms consist of smaller pieces, and these are called subatomic particles. When we break it down even further, we come up with the subatomic particles. Let us have a look at the three subatomic particles in an atom: their electrical charges, their masses, and their properties. There are three subatomic particles of an atom. These are proton, neutron, and electrons. This figure shows the location of three subatomic particles in an atom. As we can see in the figure, we can see that protons and neutrons are found in the nucleus of an atom, while electrons are found outside the nucleus of an atom. So what is atomic nucleus? Atomic nucleus is a positively charged center of an atom. This consists of two subatomic particles that are bonded together by a very strong nuclear force. These are protons and neutrons. It is also called as atomic nucleus. The word nucleus comes from the Latin word nucleus, which is a form of a word nux, which means nut or kernel. First subatomic particle is proton. Proton is the most basic unit of an atom. This is because the number of protons in an atom determines its identity of an element. Technically, a solitary proton can be considered as an atom of an element, like in the case of hydrogen. Proton is located inside the atom's nucleus. Proton is positively charged particle. The mass of proton is 1.6720 times 10 to the negative 24th power grams. Second subatomic particles is neutron. Neutron is one of the subatomic particles that is located inside the atomic nucleus. Neutrons are approximately the same size and mass as proton, but they lack a net electrically charged or this is electrically neutral. The number of neutrons in an atom does not affect its identity, but does determine its isotope. The net charge of the neutron is zero, although each neutron consists of a charged subatomic particles. The number of neutrons in an atom does not affect its identity, but does determine its isotope. The net charge of neutron is zero, although each neutron consists of a charged subatomic particles. The charge of neutron is no charge. That is why it is considered as neutral. The mass of neutron is 1.6750 times 10 to the negative 24th power grams. This is the reason why neutron is slightly larger than that of proton. The third major subatomic particle of an atom is the electron. The electrons are much smaller than protons and neutrons, and typically orbit an atomic nucleus at a relatively great distance from its core. To put the electron's size in perspective, a proton is 1,863 times more massive than the electron. Because the electron's mass is so very low, only protons and neutrons are considered when calculating the mass of an atom. Electrons are located outside the atomic nucleus. Electrons orbit an atomic nucleus at a relatively great distance from its core. Because electrons orbit around the atomic nucleus, they are the subatomic particles that affects the chemical reaction. The charge of the electrons is negative, and the mass of electrons is 9.109 times 10 to the negative 28 power grams. This is the reason why electron is very light compared to other subatomic particles. We need 1,863 electrons in order to equate the mass to the proton. Now that we know the three subatomic particles of an atom, this time let us discover the scientists who discovered the subatomic particles. The first scientist who discovered about the subatomic particles was Joseph John Thomson or J.J. Thomson. He discovered that atoms were not indivisible but composed of subatomic particles that are electrically charged electron embedded in it, a positively charged mass. His experiment proved the existence of the negatively charged subatomic particles called electron. So he was the first one to discover the negatively charged particles, and that is electron. The second scientist who discovered about the subatomic particles was Ernest Rutherford. Ernest Rutherford used the gold foil experiment to observe a deflection of an alpha particles as it passes through a very thin gold foil. It led him to discover the positively charged particle in the nucleus of an atom, and he called it proton. The third scientist who discovered about subatomic particle was James Chadwick. Chadwick's experiment was cleverly designed because he was a tough problem to solve. How do we find the existence of the particle that has no charge at all? He decided to create a chain reaction. In his experiment, Chadwick shot alpha particles radiation at a very thin sheet of beryllium. The radiation knocked neutron out of a beryllium atoms. These neutrons did knock positively charged proton out of a disk of a wax, which were picked up by a detector. Based on the amount of protons that were detected, Chadwick was not only able to prove the existence of the neutrons, but also that they were able to discover that they have the same size as a proton. There are also models of subatomic particles. First model of subatomic particles is the planetary model, wherein we can find the proton and neutron inside the nucleus and the electrons are orbiting around the nucleus. The second model of subatomic particles is the nuclear model. So inside the nucleus are the protons and neutrons, and outside the nucleus are the electrons. The third model of subatomic particles is the electron cloud model. This is discovered by Erwin Schrödinger. In this model, we can see that the electrons are in the electron cloud portion, and the proton and neutrons are found inside the nucleus. There are also models of an atom. The first model of an atom is a solid sphere model. This is discovered by John Dalton in 1803. Another model of an atom is the plum pudding model. This is discovered by J.J. Thomson in 1897. Another model of an atom, the nuclear model of an atom. This is discovered by Ernest Rutherford in 1911. Another is the planetary model of an atom. This is discovered by Bohr in 1913. The last atomic model is the quantum model, discovered by Schrödinger in 1926. The three subatomic particles are proton, neutron, and electron. Proton is a positively charged particle located at the nucleus of an atom, which made up the mass of an atom. The neutron is an uncharged particle located at the nucleus of an atom, which also made up the mass of the atom. Third is the electron, a negatively charged particle located outside the nucleus of an atom and can transfer from one atom to another. To summarize everything, there are three subatomic particles, the electron, proton, and neutron. The electron can be written in a shorthand notation as E negative. The charge of electron is -1 or negative, and the mass of electron is 9.109 times 10 to the -28 power grams. Second subatomic particle is proton. The shorthand notation of proton is P+. The charge of proton is +1 or positively charged, and the mass of proton is 1.672 times 10 to the -24th power in grams. The third subatomic particle is the neutron. The shorthand notation for neutron is NO. The charge of neutron is 0 or uncharged. And the mass of neutron is 1.675 times 10 to the -24th power in grams. For enrichment, let's have to perform the activity. For activity 1, this is entitled A Big Difference. This activity was adapted from the grade 8 learners module by Campo. The direction is use the values of the converted masses of subatomic particles to complete the bar graph. So the given is and the table 2, that is the masses of the subatomic particles. Okay, for proton, this is given. So the mass of proton is 16,720 as converted already into times 10 to the -28 power. So proton must be here. For neutron, since they have almost the same, 16,750, so we'll make a bar almost the same as in proton, so here, but a little more greater than proton. For electron, the mass is only 9.109, so if this is 2,000, we'll divide this one into 2,000 and you will get a 10 here. So as we can see in the bar graph, really electron is very light in terms of mass, and protons and neutrons are almost the same in mass, but neutron is much bigger compared to heavier compared to proton. Okay, let's answer the question. Question number 1. Which among the subatomic particle is the heaviest? The answer is neutron. Question number 2. Which among the subatomic particle is the lightest? The answer is electron. Number 3. Describe the difference among the masses of the electron, proton, and neutron. So if we're going to describe the difference in terms of their masses, we can say that the heaviest is the neutron, followed by proton. They're almost the same in terms of mass. And the most or the lightest mass is the electron. Number 4 question, which among the particles contribute mostly to the mass of the atom? The answer is proton and neutron. Okay, another activity, activity 3, entitled How Heavy Am I? So in this activity, you are asked to add all the masses based on the table below. This is the conversion of the amount of masses of electron, protons, and neutrons in times 10 to the 28th power in grams. So in the given, I am helium. I have 2 protons, 2 neutrons, and 2 electrons. How heavy am I? Okay, we all know that there are 2 electrons. The quantity of electron is 2 times its mass. It will give you 18.218. In terms of proton, how many quantity? The quantity of proton is 2 protons times its mass 16,720 times 2. The answer is 33,440. Third, the neutron. The quantity of neutron is 2 since there are 2 neutrons. You multiply it with the mass, 16,750. The answer is 33,500. To get the total mass, we have to add the 3 masses. 18.218 plus 33,440 plus 33,500. So the total mass of helium is 66,958.218 times 10 to the 28th power grams. So this is because, take note, a stable element will have the same number of protons, neutrons, and electrons. As you can see in the number of protons, neutrons, and electrons of helium, they are the same, 2 protons, 2 neutrons, and 2 electrons. So therefore, this element is stable. This ends my video lesson. Thank you for listening. I hope you learned something from my discussion. This is Mom Debbie saying, God bless you all.